Hello friends, welcome to my channel. Let's have a look at problem 2510. Check if there is a path with equal number of zeros and ones. In this video, we're going to share a solution based on Traversal. So here we're going to use depth-first search. And in this video, we're going to share a solution with iterative format of depth-first search. So in a follow-up video, we're going to write a solution with recursion and cache. So first, let's look at the problem statement. We are given a zero-indexed m by n binary matrix called grid. We can move from a cell at row and column to any of the cells row plus 1 and column, and row column plus 1. In other words, we can move downwards or rightwards. Return true if there is a path from 0, 0 to m-1, n-1 that visits an equal number of zeros and ones. So the condition is that we need to visit an equal number of zeros and ones in the path. So there are two examples. So in example 1, the output or return is true. So in the explanation, it marks a valid path which contains 3 zeros and 3 ones. So in example 2, so the output or return is false. So with that said, let's also look at the constraints. First, the number of rows and the number of columns are m and n respectively, and m and n are bounded in between 2 and 100. So the matrix is a binary matrix. So with that said, actually we are ready to analyze the problem and writing the code. So as we mentioned at the very beginning, so this problem is a standard traversal problem. So we can use depth-first search or breadth-first search. So in general, so the time complexity of these two methods are the same. However, here I feel that most of the time, so the depth-first search is a little bit faster, so empirically. So with that said, so we would like to coding with a iterative format of depth-first search. So because of this intention, so we're going to use a stack abstract data type. So with that said, let's do the coding. So we are going to delete the coding into different parts. So the first one, so we are going to make some preparations. For example, let's track or retrieve the number of rows and the number of columns. That is length of grid or length of grid 0. So, and then also we need to make some preparations on the direction we can move. So I'm going to use dr. So we can move downwards. That is, we add the row index by 1. So, or we can walk rightward. So we add the second component by 1. So these are the two directions. So next, so we're going to do the depth-first search. So here I'm going to use iterative format. So for this, I'm going to initialize a stack. So initially the stack contains one tuple. So here the stack is going to store the RC or XY. See, you can see the number of ones and the number of zeros, right? And then I'm going to initialize a set called visited. So this is used to aid the depth-first search and avoid repetition. So here we are going to store the positions and the difference between ones and zeros. So you can use n ones minus n zeros or n zeros minus n ones. So after all, the condition is that this difference is 0, right? It means that we have equal number of zeros and ones. So with that said, we are ready to do the while loop. So while stack. Let's first get the positions. Let's use x, y here, and n ones and n zeros. So that is stack pop. So we are going to get this information from the top of the stack. And then what we are going to do is to check the difference, that is n1s minus n0s. As we mentioned, you can use n0s minus n1s, but you need to use consistently. So with that said, then let's do a check. If x, y, and diff not invisited. So in this case, so we're going to add this tuple to the set, mean that we have visited this information. And then we are going to check if grid x, y equals 1. Then we are going to add or increment n1s by 1. Otherwise, so the grid x, y will be 0. And in this case, so we are going to increment zeros by 1, right? So this is taking the logic of the problem, counting the number of 1s or zeros when we visit a cell. And then we will need to do a check if x equals m minus 1 and y equals n minus 1. So in this case, we arrived at the bottom right. So if this is the case, so we need to check if n1s minus n0s equals 0. So or you can write they are the same, right? So if this is the case, so we're going to return true. So this is the if condition. Otherwise, so what we're going to do is that we need to put the neighbors into the top of the stack if not visited. So for r in dr, then we can write x, the new position, x bar, y bar, which is x plus r0 and y plus r1, right? And then if the x bar and y bar, the new position or new, so move down or move right, if still in bound, so it means that less than m and 0 less than or equal to y bar less than n. If this is the case, so we're going to append this information, that is x bar, y bar, and the difference, right? So so here not the difference in the visited site, so we store the difference. In the stack we store the number of 1s and number of zeros, right? So notice the position, so we need to use it consistently. So once this done, so if during the while loop nothing has returned, so we're going to return false. This forms a solution format, which is traversal based. So here, because we pop from the tail of the list and append from the tail of the list, so this is a stack behavior. We're using stack. So this corresponds to a depth first search. So I guess for now, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the test cases. So I guess that's about it for this specific problem or specific solution. So here, let me make some comments. So here, actually, we pop from the tail. So if we pop from the head, so this corresponds to a queue behavior. Then the code will correspond to a breadth first search. So let's also check this case. Yeah, it seems that the breadth first search takes more time. So now let's, in order to do it accelerate a little bit, here we can change to collections. So we can use a deck. So here, and then here we changed to pop left. So let's check again. Yeah. So this is a typically if we use the queue for breadth search. I personally typically use this collection stack and data tab. So let me restart the original code. So this original code is corresponding to depth first search. Let's test. Yeah, so I guess that's about it for this problem and this video. In a follow-up video, we're going to write a solution for this same problem using recursion and cache. So that's also a typical technique to solve this kind of problem. So you're welcome to check out. So with that said, that's it. Thank you.